I think that in neuroeconomics today there is a misunderstanding, an important misunderstanding, because there is not enough connection between, on the one hand, the neuroscience of decision making, and on the other hand, decision theory, which is a branch of economics, of economic theory, of mathematics even. And so there are two communities, two scientific communities, who try to address a subject, a unique topic, but they don't speak to each other so well. The topic is, what is decision? What is a decision? How should we model decision? How should we understand our ability to make decisions? And my idea is to connect those two communities. I'm not the only one, of course, to want to do that, but the idea is to connect those two communities, and I'm not so sure that we reach a level of a mutual understanding. So I will try to see where the problems lie and how we could do in order to make those two communities speak to each other beyond the tag neuroeconomics, which is not enough to define the existence of a joint community. So what is a decision? For some neuroscientists working on decision making, on the neuroscience of decision making, decision could be defined, and I will borrow my definition to a very prominent neuroscientist in that field, Shadlen. Decision could be defined as the capacity to refrain immediacy. So we have a stimulus, we have a reward, and instead of processing this reward now, or being satisfied immediately by this reward, we pause. Oh, is it a good reward? Is it a bad reward? Should I consider something else? Are there any other options in the background? What would be the consequence of, for me, of accepting this reward, of postponing this reward maybe? And this is a decision. So decision is intrinsically linked to the capacity to defer, to delay reward, in fact. This is one way of defining a decision. If we do that, we have everything that we need in neuroscience and even maybe in philosophy and decision theory in order to understand what a decision is about. Decision is about to, as I said, consider other options, think about the future. So it's already a complex cognitive framework that we have opened here. Maybe free will too. If I refrain from immediate reward, it means that I exert some kind of free will and some kind of deliberation. So we have to postpone. It's also linked to time, to the way the brain processes time, and to the way the brain processes its own reaction to its environment. So this is very interesting. A decision can be very quickly implemented in the brain. It's a matter of milliseconds. But thinking about a decision is a very long process compared to that. So this is in this contrast, in this temporal contrast, that the decision lies. So neuroscientists, they are mainly interested, or at least neuroscientists like Shadlen, for instance, are mainly interested in this topic. And I feel very close to this kind of neuroscience, in fact, because this is neuroscience trying to understand some deep philosophical issues. Free will, decision-making, responsibility. Okay. On the other hand, we have decision theory, which at first blush has nothing to do with that. It has an idea of a decision as a very abstract model. We have preferences over a set of options, and we try to maximize our utility given those preferences. So the vocabulary even is very different. So how could we try to make those two things fit together? I'm not so sure that most neuroscientists know or are very interested in decision theory. And the reverse is even truer. I'm not so sure, not even sure, that decision theorists are not interested in neuroscience. Because why? Because, in fact, for them, the way the brain or animals maybe make decisions has nothing to do clearly with what they try to model at a very abstract level. And I don't agree with that. I think that we should develop a decision theory which is in connection with neuroscience or with biology or with psychology, in fact. I wish to develop a decision theory which is homeomorphic to the way we are. What does it mean? I borrow this phrase homeomorphism, homeomorphic, to a very prominent decision theorist, Peter Walker, who contrasts between paramorphic models in decision theory and homeomorphic models in decision theory. Paramorphic models are models that model decisions in abstraction from what we do, in fact. The mathematics is not connected to what we do. Okay? It's something else. It's an as-if model. Homeomorphic models, those are the models that try to make sure that the logical ingredients, the logical steps that we find in the models reflect to some extent what we do in reality when we make a decision. So there is a kind of homeomorphism between decision making, as we do it, and decision theory. So it's difficult, because as I said, the neuroscience of decision making is interested by some processes in the brain, maybe some inhibition processes in the brain, for instance, not responding to a reward too soon, and decision theory models the connection between preferences on one side, the algebra of preferences, and a utility function. Nothing to do. I mean, very two different universes. So how to connect that? I will give my own recipe and see whether it works or not. My recipe is that decision theory, I mean the abstract part of decision theory in economics, in economic theory, in fact, speaks about a psychological ability, speaks about the same ability that we study in neuroscience, the ability to make decisions. It speaks in a certain way, with a certain vocabularies, with a certain ontology, but it speaks of it. So we should try to model this very fact, mathematically, in fact. Do we have preferences? Can we see preferences in the brain? Do we have beliefs? Can we see beliefs in the brain? I don't think that we can see such things in the brain, but what we can see is, for instance, at a behavioral level, when we make inconsistent preferences, for instance, by violating transitivity or something like that, some basic rational patterns that we should observe when we make differences, otherwise we're not rational. When we violate transitivity of preferences, for instance, or when we have inconsistent beliefs. I believe A, and 2 minutes later I believe non-A. This is inconsistent logically. When we do that, maybe without realizing that at first, is there something in the brain that happens that say, oh, there is a mistake here? Okay? So maybe we don't see preferences. We don't see this kind of algebraic structure in the brain. We don't see probabilities in the brain, subjective probabilities in the brain. I'm not sure that we can see that. Some people say that they can see that, but I'm not so sure that they have seen that. But maybe what we can see is when we don't comply with those models, those basic probabilistic structures or basic preferential structures, when we don't comply with them, when we make some mistakes from a normative point of view, maybe we realize that more or less consciously. Maybe there is something in the brain that say, oh, mistake here. So there is a conflict, probably in the anterior cingulate cortex taking place. And I am interested in those markers. I call them neural markers of rationality. Here we have a little point. It's a bit like the pineal gland in Descartes connecting the body and the soul, but it's not like that. It's something in the brain, maybe in the ACC, that says, oh, that connects some views about our rationality and some action we perform and that are not so good for us, or that we realize are not so good, so we should refrain from doing that. And this is again decision, in fact. So I think there are some ways to connect a decision theory and the neuroscience of decision making. So just let me tell you about an experiment that I ran some years ago about a very famous paradox in decision theory, which is the Allais paradox, and which amounts to a violation of the axiom of independence in decision theory. That the fact that if we have two options and they have a common part, we should make our decision without taking into account that common part. We should take in our decision only into account the part that differs, because this is where the important information lies. So some people just don't do that. Most people, in fact, don't do that in some context. They violate this principle of independence, and so they reach some inconsistent decisions. Okay? So this is a very famous experiment, a very famous paradox in decision theory, and I did, in fact, run that experiment with some brain lesion patients in a hospital in Paris and in other hospital in Toronto. Those patients, they had a lesion in the frontal cortex, Actually, it was a behavioral frontal variant dementia. And so we gave them the ALE problems with this problem of independence. And most people, as I said, most non-lesion persons, they violate the axiom of independence. And those people didn't violate. None of them did violate the axiom of independence. They were perfectly rational. Well, this is a published paper that shows that some brain lesion patients are more rational as far as the independence axiom is concerned than healthy subjects. Or is this a problem? Should we have part of the brain lesion in order to be rational? You see that if we follow decision theory in its prescription of not violating the axiom of independence, it means that it will be easier for us to just cut a part of our brain. That's a problem, I think. So it means that here there is a kind of discrepancy between the brain as it is and decision theory. So it doesn't mean that decision theory should be taken too normatively or prescriptively. It's only mathematical construction or philosophical construction. It's an abstraction that describes to some extent what happens in the brain and what we do, and that should describe even more what happens in the brain and what we do, but not into a direct way, because otherwise we'll find not the ALE paradox, but the paradox of brain lesion persons not violating the ALE paradox.